And once you have a proper rational expression, so we have a proper rational expression of the form p of x by some q of x. So every proper rational expression can be expressed as sum of proper rational expressions, whose denominators are the simple factors of q of x. For example, if you have some x plus 2 by x square minus 5x plus 6. So x plus 2 by x square minus 5x plus 6 is a proper rational expression. The degree of numerator is 1, the degree of denominator is 2. Now, if you factorize the denominator, it is x minus 2 into x minus 3. So what this statement says is, every proper rational expression can be decomposed into fractions whose denominators are the simplest factors of the main denominator q of x. That is something by x minus 2 plus something by x minus 3. So I can decompose x plus 2 by x square minus 5x plus 6 into sum of two fractions whose denominators are factors of the original denominator. And these two fractions are called partial fractions. So every proper rational expression can be decomposed into partial fractions. So something by x minus 2 plus something by x minus 3. So here the partial fractions will always be proper fractions. The partial fractions will always be proper fractions. So keep this in mind. So partial fractions, that is, the fractions that you get after decomposition are always proper fractions. That is, the degree of numerator will always be less than the degree of denominator. So if I decompose x plus 2 by x square minus 5x plus c into partial fractions, so the denominators are x minus 2 and x minus 3. The numerators are right now unknowns, but they have to be constants because the degree of denominator is 1. The degree of numerator has to be 0 for this to be a proper fraction. So x plus 2 by x square minus 5x plus 6 can be decomposed into two partial fractions, one of which has denominator x minus 2, the other of which has denominator x minus 3. Now how we find a and b? So that constitutes the method of decomposition into partial fractions. There is a proper method by which you can decompose any given proper rational expression into corresponding partial fractions. So now let us understand by a few examples how to do this.